at number 6. I'll use the same approach, and I recommend you do too. Limit as x approaches a of f of x. So here's my f of x. They called it y, but we know better. So x squared minus f of a, which is just the same thing but with a plugged in for x, over x minus a. All right, so factor at the top, much easier, right? The grouping is irrelevant. It's just x plus a, x minus a. The x minus a's would cancel, and we'd have the limit as x approaches a of x plus a. And again, the fact that x and a are getting closer and closer to one another gives us license. Gives us license to replace x with a or a with x. All right. Most of the time, we need a function as an answer. So again, I want to replace. Generally, I want to replace the a. All right. So that's going to become x plus x, which is equal to 2x. All right, so that's my f prime of x. That's my derivative. I want that to happen when x is equal to 3. So 2 times 3 is equal to 6. And that's the slope of the tangent line. They didn't ask us to do anything more than that, like find the equation of the tangent line or anything. So we're in good shape. It said find it at the point 3 comma 9. That was a little bit of extraneous information. I didn't need the 9 in order to find the slope. But if the question said find the equation of the tangent line, knowing that 9 would be helpful, although not necessary, because if I have the function, I can always figure out the y that goes along with the x that I'm given. So in this case, I didn't need it. In some cases down the line, I might. We'll see how that goes. All right. Right now, we're just focusing on slopes for the most part. We'll incorporate equations later on. It's not really much of an adjustment. Find the slope of the tangent line to the graph of y equals the cube root of x at x equals 0. All right, so this is where we earn our keep. Limit as x approaches a of f of x minus f of a all over x minus a. All right, when you have binomials that contain roots in any way, shape, or form, cube roots or otherwise, it means you have some work to do. Right? Also, we know that through direct substitution, and this is something that goes back to the last unit, but we don't always pay it much attention. If I were to evaluate this limit right now by replacing all of my a's with x's, I would get 0 over 0, which is indeterminate, which means I can get an answer as long as I'm willing to do the algebra. All right, that's what it meant in the last unit. That's what it means in this unit. That's what it's always going to mean. Right? So in this case, it's not very exciting because what it is telling us is that I can't just walk away from this problem and say, no solution. Although, fun fact, the answer ends up being no solution, but not because there isn't an answer, but because it's like no solution for slope, which means it's vertical. All right, so spoiler right there. But we actually can do something with this algebraically, and we have to. And you're very excited about that. I can tell by the looks on your faces. All right, so I rewrote the top because we're actually not going to do anything to the top. It's the bottom that we're going to adjust, which is kind of surprising, I would think. Let's see, does red show up? That's a little better than the green. It's not very appealing, but we'll live with it. So we're going to factor x minus a. But we're going to factor it as if it's a difference of cubes. Which is kind of a surprising approach to take, because you wouldn't think that you'd be able to factor something if it's already raised to a power of 1. But if it's a binomial, it's factorable. You just might not like what happens when you factor it. Like, for example, just off on the side, I'll show you real quick. If I wanted to factor x minus a as if it were a difference of 2 squares. When I factor a difference of 2 squares, I take the square root of the first term, and I take the square root of the last term, and then I alternate the signs. One should be positive and one should be negative. Right? Not a very pretty answer, but definitely pretty useful. I saw some folks trying to do that on the last unit test. I thought that was pretty cool. All right, but here we want to do is difference of 2 cubes. So in order to do that, we need to know how to factor a difference of 2 cubes. So let me just state the rule. A squared minus b, oh, sorry, squared. I got squared on the brain. A cubed minus b cubed. And that's going to be equal to a minus b times a squared plus ab plus b squared. And that trinomial is not factorable generally. Maybe there's a GCF in there, but not factorable as binomials. So I want to apply this. So we'll kind of dissect this. In order to get from this term to this term, we took the cube root. Same idea here. Both cases we took the cube root. To get from the first term in the binomial to the first term in the trinomial, we squared that. Same thing with the last terms. To get the middle term, we took the 2 terms of the binomial and multiplied them. Alright, so that's more of those obscure topics in Algebra 2 and Pre-Calc. It's like, yeah, let's learn how to factor in the sum and difference of 2 cubes. Why? Just because. Sure, it'll be important later on. And then you learn how to do it, you got tested on it, maybe it came up like twice more before the course was over, and then that was the end of it. Right? But now, looking at this kind of problem, it's more or less implied that you should not only know how to do it, but you should know that that's an option going into a question like this. All right? So you got to kind of add that to your list of strategies and say, if I see a cube root in the form of a binomial, maybe factoring an expression is an option that I should take. All right. So I want to do the same thing to x minus a. And honestly, full disclosure here, I never remember the rule. Like in A and B stuff, I never remember that. Like if you asked me on the fly to just state the rule, I wouldn't be able to just rattle it off my head. What I do is I follow this idea, all these little notes that I made. I follow that approach to get me my factored form. Right? I know that I'm taking the cube root of the first 2 guys in order to get me my binomial. And then I square, multiply, square. Cube root, I can't even speak it. It happens nicely in my brain, but out loud it's a disaster. Cube root, square, multiply, square. Cube root, square, multiply, square. The sign distribution is a little different. I'll get to that in a minute. But at this point, I just need to know I'm taking the cube root of these guys. So cube root. Then I'm going to square each of these guys. So the cube root squared. Now, I can apply that power of 2 to just the x within the cube root, or I could have the cube root of x in parentheses squared. They're both equivalent, it doesn't matter. All right, I'm going to do the same thing with this one. And then I'm going to multiply the two together. And that's going to give me my middle. So I'll do that in a different color than green, because green seems to be not good. So I'm going to multiply these two. That's terrible. These two get multiplied. So XA.
Now for plus or minus yet?
What's that?
Do you know if it's plus?
Not yet. That's what I'm about to explain. So we use the SOAP acronym to help us determine the signage. That's assuming that you don't just memorize it. There's always minus plus plus when it's a difference. It's always plus minus plus if it's a sum. But it's just like a weird fact to know. Like that's like a weird bit of trivia that if you were to lay that on someone, they'd be like, okay, cool. That like nobody cares. So, but this might be a little bit better. I mean, I guess you care if it gets the job done, but I found that people like this better. The SOAP acronym, same, opposite, always positive, tells us that the signs of my expanded form, as they relate to the original sign, first one should be the same. So that would be a minus in this case. The second one would be the opposite of the original, so a plus. The last one is always positive. So rather than memorizing minus plus plus and plus minus plus, you can memorize what this is. Bottom line is you got to memorize something. I've seen people program that kind of stuff into their calculators. That's fine too. I don't really care. This isn't calculus. This is algebra. So write a program where that's the subject of the program. I mean, it's not going to factor anything for you, but at least it'll be in there. The display feature is really nice when it comes to that. I'll pause real quick. I'm stealing my own time, but this problem is pretty much done now that we have this. That you've done something right here. Because if they didn't cancel, then you done did it wrong. So cube root of x squared plus cube root of xa plus cube root of a squared. Apologize for the handwriting. The troublemaker was the cube root of x minus the cube root of a, because if I substituted into that, I'd have a problem. But substituting in now, replacing all my a's with x's, I'm not going to have a problem at all because it's not going to make my denominator undefined. So what we have here are three separate instances of the cube root of x squared. Just the middle one's written a little differently because it was written as x times a, so I changed that to x times x, but that's the same as x squared. So what does it simplify down to? 1 over what? How many of the cube root of x squared do I have? 3 of them. And so that is going to be my f prime of x. That's my derivative.
It's x cubed, isn't it x squared?
It is x squared. Thank you. We're being obnoxious? No. simplify it. Plug in a 0 on the bottom, you get 0. This does not mean DNE. It does not mean no solution. In this case, and we'll talk about different cases starting tomorrow, but in this case, based on the graph, if you were actually to graph the cube root of x, which looks something like this, we're talking about this location here. It has a vertical tangent. All right, but really all we didn't need to draw that conclusion. We just needed the number 1 over 0 as the slope at that particular point. So we'll talk about cases when you get 1 over 0, cases when that means that there is no solution versus cases where it means it's a vertical tangent. We'll do that tomorrow.